and welcome to this presentation on programming at Middleton Robotics. Now here is an overview of the presentation. We will be covering programming for robotics specifically, the programming process, and the elements of programming. This includes languages and syntax, variables, logic and control structures, and functions. I will not be teaching specific syntax for the programming languages, as that is far too complex to cover over the span of a single video. Now, on to our first section, programming in robotics. Programming in robotics is specifically centered around the robot and is used to control the robot, of course. Programming is not done by a single person or just the programming team, but must rely on working with other members of the team. For instance, programmers should work with the design team to understand how many motors they will have to program for in the final product. Finally, they will be programming for a competition within a specific game. The game usually has two portions, autonomous and teleoperated, which will be covered in detail on the next slide. There are two main modes during every match. Usually, the match will start with an autonomous portion. This is because it's easier to ensure that all of the game elements are in the same places as you practice with. In auto, the robot follows whatever instructions it was pre-programmed with. The driver will not be able to control the robot until the time is over. It is important that the programmer coordinates with other teams to ensure that their auto and the other team's auto can both function correctly. The second portion is the teleoperated portion, which means that the driver can now control the robot. Now, we move on to the programming process. The process consists of 6 main steps, which are program specification, designing the program, coding the program, testing, fixing, and then you are finally finished with programming. The process is more iterative than this, which means that it usually doesn't just follow this straight path, but one may have to go back and adjust the design or the specifications or the code as they continue through the process. Programming usually never reaches an end. It is more of when the programming can't be worked on anymore. There will always be something that can be improved in the program, just like the robot's design itself. The first step is program specification. This step is when the programmers specify what exactly they need the robot to do for that specific game. This requires them to first understand the game, which is what they'll do at brainstorming. They also need to collaborate with the designers to plan for what components are going on the robot, such as the number of drive motors and what sensors they are planning to use. The next step is to design the program. This is where most of the logic comes in for programming. Programmers will develop flowcharts to help them envision what exactly they will need to do, as well as the pseudocode to help them transform their flowchart into code later. The flowchart shown here is a basic example of what one might see when they are creating their own flowchart. The rectangles are to represent a specific action, such as turning on or off a motor. The rhombus's represent a decision that is to be made. The parallelograms represent an input into the system. This could be driver input or from a sensor. The third and most commonly known step is to finally program the code. Here, the programmers will transform what they designed into computer language that the control system on the robot can understand. Once the code is written, the next step is to test the code. They have to ensure that the code works properly. This is often the hardest part of programming because it heavily relies on the team getting the robot itself built and wired up. They will need to work with electrical team members to ensure that all of the parts are plugged into the correct ports corresponding with their program. This step allows them to find any errors that they need to fix and fix them so that the robot performs correctly before competition. Now, we are moving on to the final section, which is the elements of programming. The first part that we have in programming is the specific language and the syntax for that language. The correct language and syntax must be used to ensure that the robot understands what you have programmed. Syntax refers to how specific statements are written and formatted, such as what brackets to use and how the end of a line of code is defined. FRC and FTC both use Java for their robots. They do have the option of using C++, but none of the first teams at Middleton use it. Vex uses Robot C, which is a special language that they designed for their own robot competitions. It is based on other C languages. Variables are an essential part of any program. They assign a value to a defined name. The value can change to represent a data source, such as the number of rotations tracked by an encoder or the speed of a motor on the robot. The value can even be a mathematical calculation, such as using the speed of a motor to determine the speed of the robot itself. There are a variety of different variables. For instance, there are Boolean variables, which are true or false, characters, which are any alphanumeric character or a symbol, integer, which is a whole number, or float, which is a decimal. There are many more complex variables as seen in the hierarchy chart to the right, but these are the basic ones that will be used the most often. Next are the logic and control structures. These help to determine how and in what order code is executed. First is a sequence. The code is executed in a distinct pattern from start to end. There is no deviation from what is written. This is generally not used in robotics because it's too rigid and offers little control over what is being done. Next is selection. This often uses an if, else if, then structure. Basically, the code will reach a decision. It will then determine if the decision is true or not. If it is true, it'll do a certain thing. If it's not true, it'll move on to the else if and determine if that's true or not. If that's not true either, it'll move on to the then statement and will continue moving on. The decision will often compare variables to each other, which can change frequently during the execution of the code, which is why variables are often used. The last is loops. This code will continue to run on repeat and complete the same action as long as the statement is true. It is similar to a decision or a selection where it will make a decision on what it needs to do, but this one repeats infinitely as opposed to a selection which repeats once. Functions are a highly powerful element of a program. They allow for the total amount of programming work to be divided among programmers on the team. Each specific task is put in its own function to help organize the code. This makes searching for a specific code that needs to be fixed much faster and easier, as one only needs to search for a specific section as opposed to the entire program. As you can see in the graphic, a program has a main section where functions are called, and each function then has its own section within the overall body of code. The program will then jump to a specific function and execute the code in that function while still executing code in the main program. The main program will then only have function names as opposed to including the code for each of the functions of the program. And now we have reached the end of this presentation. Thank you for watching it, and I hope you learned something or it helped to determine what you want to do on a robotics team. Please follow us on this YouTube channel for more robotics-related content. Have a nice day.